Deciding if an object is in motion is not as easy as you might think. For example, you are sitting right now. So are you moving? Freeze. As still as you can. Are you moving? Well, parts of you are. Your eyes blink. Your chest moves up and down as you breathe. But when you freeze, you would probably say you are not moving. Scientists define an object is in motion if its position changes relative to another object. So scientifically, when you freeze, your position relative to your chair, desk, and other things in the classroom, you would say that you are not in motion. This is called a reference point. A reference point is a place or object used for comparison to determine if something is in motion. The best reference points are things that don't typically move. And here's some examples. Stop sign does not move typically, so it would be a good reference point. Same thing as a tree or a building. Let's watch a video that explains this concept a little bit more.
In order to describe the position of an object, you need a reference point and a set of reference directions. It is difficult to describe the position of the car because we do not have a reference point. A reference point can be any object. In this case, we will use a tree. Note that the reference point can also be referred to as the origin. The car is in front of the tree. We use the tree as our reference point and in front of as our reference direction to help us describe the position of the car. A plus sign or minus sign can be used to express the position of an object relative to the reference point. Here we use a plus sign to show that the car is in front of the tree. Now, the car is behind the tree. The tree is still our reference point, but now the reference direction is behind. We use a negative sign to show that the car is behind the tree. Let's move the car to the right of the tree. Again, the tree is our reference point, and the new reference direction is to the right of. We use a plus sign to indicate that the car is to the right of the tree. Now we'll move the car to the left. We use a negative sign to express that the car is on the left side of the tree. Along with a plus or minus sign, the position of an object can be described as a distance from the origin. For example, the green post is plus 5 meters from the tree. Or, the red post is plus 15 meters from the tree. In both cases, the plus sign indicates that the green and red posts are to the right of the tree. Notice that the blue post is minus 5 meters from the tree, and the orange tree is minus 10 meters from the tree. The minus sign indicates the blue post and the orange tree are to the left of the tree.
So when you froze to your spot, before we showed that video, I had you freeze right to your spot. If you used a chair as a reference point, as you sat, you would be considered not moving by using the chair as the reference point. But what if you chose another object as your reference point? Would you be moving? Suppose you use the sun as a reference point instead of the chair. If you compare the position to the sun, you would be moving Actually, quite rapidly, about 19 miles per second. So the next time someone asks you, how fast can you go? You can say you can go about 19 miles every second. Relative motion, that is. To the sun, of course. Relative to the sun, both you and your chair are in motion, but because you are moving with the earth, you do not seem to be moving. Let's watch a video that explains this concept. Watch the path of the balloon as it falls to the ground. Was the path straight or curved? Remember, you're thinking of relative motion. Let's watch it again from a different point of view. Relative motion from the inside of the car, from the outside of the car. Is it straight or is it curved? Which one do you think? Look at them both at the same time. Relative to the direction. Straight or curved? What do you think? It's both. Trick question. It had to do with relative motion. The path of the balloon depends on your perspective. Different observers report different facts. Okay, so I know that was a trick question. I know. So to describe motion completely, you need to use units of measure. So they use measurements. It's a different kind of measurement system that we used compared to the rest of the world. So we're going on to the final term that we're learning today in our lesson. So we just learned about the motion as the first concept, and then the relative motion and the reference point of those. But now you need a unit of measure to be able to bring that all together. Scientists use a system of measurement called the International System of Units. And I wanted to have you listen to a song that helps describe the International System of Units, so that you can kind of get an idea of how it is done. It is actually on a number system by tens compared to our system. So let's watch this song from Number Rock. The metric system.
1,000 kilo, 100 hecto, 10 is decameters, 1/10 deci, 100 centi, 1,000 is millimeters, 1 decameter is 10 meters, 1 hectometer is 100 meters, 1 kilometer is 1,000 meters, and here is how we remember 1,000 kilo, 100 hecto, 10 is decameters, 1/10 deci, 100 centi, 1,000 is millimeters, 1 decimeter is 1/10 of a meter, 100th is a centimeter, 1 millimeter is 1,000th of a meter, and here is how we remember 1,000 kilo, 100 hecto, 10 is decameters, 1/10 deci, 100 centi, 1,000
how the International System of Units is set up to describe different aspects of science. Now, most countries, let me get this map up for you to show you, most countries use that type of system. So everything in green uses the international system or the metric system. There are 3 countries, let me circle them for you here. There are 3 countries, including the United States, that use the imperial based, and it's based off of feet. These are the only 3 countries in the world that don't use the international system or the metric system. They use the imperial system. So let's watch a short clip from my guy, Bill Nye, that explains why it is easier to use the metric system than the imperial systems. And then we're going to see some Americans trying to convert our system to the rest of the world.
Moments in measurement. A long time ago, people used to measure things with their own body parts, like feet. This guy's foot was 1 foot. Later, it was the king who declared that his foot, the royal foot, would be the foot that all feet would be fitted against. It was the standardization of the foot, and it was quite a feat.
Humans are about this big, so we've always wanted a unit of measurement about this long. And we want it to be the same for everyone. We want it to be a standard. That's why it's hard to use something like a foot, because not everybody has the same size feet. So what we did is we looked at the Earth, and we divided the distance from the North Pole to the equator in 10 million times. And we got this. It's a meter. We use 10 because humans have 10 fingers. Now you can keep going. You can divide a meter by 10 and 10 again, and you get centimeters. There are 100 centimeters in a meter, just like there are 100 cents in a dollar. You can divide it by 1,000, and you get millimeters by a million, and you get micrometers. It's easy. With a meter, you can measure just about anything. This microphone is about 32 centimeters long.
What?
It's the metric system. It's easy.
What?
So that's the metric system, which we use in America, the imperial system, not the metric system. So it can be, even though the metric system is much, much easier to learn, we learn the imperial system, so it can be kind of hard for Americans to be able to transfer them. So let's go over to a BuzzFeed episode and see some Americans trying to figure out the metric system.
All these videos recently are designed to reveal me as an idiot.
So you knew that the United States is one of only 3 countries that have this system.
Give me them tens, give me them hundos, give me them thousands.
Liters instead of gallons, and instead of miles, there's kilos.
It's confusing to me how kilometers are shorter than miles, but meters are bigger than feet.
It seems like the metric system makes a lot more sense than our system.
Yeah, ours is dumb.
Okay, so their task 1 is to identify 1,000 milliliters.
I don't know how much a milliliter is.
I think a milliliter is small, therefore this is 1,000 milliliters. This one.
1,000 milliliters, right there. I picked this one because I know what a 2-liter bottle looks like.
Aha. Next task, build a tower 45 centimeters
Like
tall.
4 centimeters in an inch, sort of.
So if you can approximate an inch, which you can't, you can figure this out, which you can.
Yours is much better than mine.
Mine could also be a spaceship.
It's like a Great Dane and a Chihuahua. Oh my gosh, that's huge!
Okay.
I'm not super embarrassed about this.
I thought hers was going to be way too long.
I feel defeated.
Pretty good, guys.
Oh.
Task 3, dress for Celsius. The temperature, negative 5 degrees
Fahrenheit is 0
Celsius.
It's going to be in the 20s, is my approximation, so pretty cold.
Put it all on. So it's really hot. Put on this scarf.
draw these up.
Okay, hi.
Put the glovies on because we don't want your fingers getting cold.
Thanks.
Put that on and zip it.
So remember, we do Fahrenheit. The metric system does Celsius. So they're trying to figure out and convert Celsius to Fahrenheit.
If it was negative 5 degrees Celsius, this is what he should be wearing. I should probably be wearing more things, honestly.
You've dressed me the right way for 23 degrees. I get cold in like 80-degree weather.
So negative 5 degrees Celsius was 23 degrees Fahrenheit. 23 degrees is awfully cold. So this guy, she did not dress him correctly, did she?
So this is going to be real cold. 23 degrees Fahrenheit? That's like t-shirt weather back in Minnesota.
Now he looks a little bit more appropriate.
You're in LA, son.
Should the U.S. adopt the metric
I
system?
really wish we were just taught and we just lived in the metric system.
Americans don't like change, so I don't think this is worth it. That you learn how to do something a certain way forever, and then you're told to change it. It just doesn't work. So I think we should adopt the metric system. Come on, get on it.
Never. Yeah, we probably should. It would make a lot more sense.
And yet we don't. There's always talk of us adopting the metric system. But as the one said, Americans just do not like change. So that's probably not going to happen. So forces and energy, we were talking about describing motions in this lesson today. Hopefully you understand motion, reference point, relative motion, and what the International System of Units is, the metric system.